In the vast emptiness of space, a small chunk of ice has been drifting alone for tens of millions of years. And now, that lonely traveler has just entered our solar system. Its name is 3I Atlas. Calling it a visitor is the perfect description. Unlike the Moon, which orbits Earth, or the planets, which orbit the Sun, this object is not bound by the Sun's gravity. Instead, it's a wanderer, passing through only once before continuing its journey across the galaxy. Scientists classify it as an interstellar comet. Most of the comets we know come from the far edges of our solar system, from the Oort cloud, or from the Kuiper belt, where Pluto resides. Take the famous Halley's Comet, for example. It's still just a periodic visitor that loops around the Sun on a long orbit. But 3I Atlas is different. It's not from our solar system at all. It's a visitor from another star, an alien guest from beyond the Sun's reach. Naturally, we'd love to take a closer look. Wouldn't it be amazing to launch a probe right now and capture detailed images of this mysterious object? Unfortunately, that's impossible. 3I Atlas was only discovered in July 2025, an unannounced visitor that gave us no time to prepare. Designing, building, and launching a spacecraft to reach it simply can't be done in time. And since it will pass by just once, never to return, a close-up mission is essentially out of the question. For now, all we see of 3I Atlas is a faint, blurry glow through our telescopes, like watching the flicker of a candle from an incredible distance. So, what does this object really look like? Could it resemble the comets we already know? To find out, let's turn to the comet we've studied up close, Comet 67P. In 2014, the European Space Agency's Rosetta spacecraft made history by entering orbit around a comet for the very first time. It stayed there for more than 2 years, observing the comet up close in incredible detail. For the first time, we could see what a comet really looks like, not just drawings in textbooks or artists' impressions, but its true, rugged surface. The object you're seeing here is Comet 67P. It looks like two chunks fused together, almost like the shape of a rubber duck. And the surface? From far away, it appears smooth. But up close, Rosetta revealed towering cliffs, deep valleys, and jagged mountain-like formations. In some regions, ice was heated by the sun, turning into gas and blasting out dust, almost as if the comet itself was breathing. Thanks to the Rosetta mission, we learned what comets are truly made of, how they are structured, and how they react when approaching the sun. 67P became the textbook example of what a comet really is. Now, let's take a closer look. How much does the interstellar comet 3I Atlas resemble Comet 67P? First, the similarities. In terms of size, 3I Atlas is estimated to be anywhere from about 320 meters up to 5.6 kilometers across. Comet 67P measures roughly 4 kilometers, so they're in the same ballpark. Both are essentially icy bodies about the size of a small mountain. And just like other comets, when sunlight hits their surface, the ice begins to sublimate into gas, shooting out dust and forming a glowing coma and tail. So, at least from a distance, 3I Atlas would likely look very similar to 67P, an irregular chunk of ice surrounded by a cloud of dust with a trailing cometary tail. But there's an even greater difference. Rosetta revealed that Comet 67P was rich in water and filled with a wide range of organic molecules. By contrast, observations of 3I Atlas with the James Webb Space Telescope produced a truly unusual result. Instead of water, this comet turned out to be dominated by carbon dioxide. And the carbon chain molecules that are commonly found in solar system comets were detected only in extremely small amounts. In other words, This interstellar object was born in a completely different chemical world from the comets we know. And the differences don't stop there. Even its color began to reveal something strange. When 3I Atlas was first discovered, it appeared to glow with a reddish hue. This color was likely caused by dust on its surface or certain molecules reflecting or emitting sunlight. But as it moved closer to the sun, a faint green tint began to emerge. Normally, comets shine green because gases released from sublimating ice are broken apart by ultraviolet sunlight, causing them to glow. In particular, carbon chain molecules are known to produce a strong green light, which is why many comets are surrounded by a glowing green cloud when seen from afar. But in the case of 3I Atlas, things get even stranger. As we mentioned earlier, the carbon chain molecules that normally produce a comet's green glow were almost completely absent here. And yet, scientists still detected a faint green emission. Could another molecule be responsible? Or is there some kind of unusual chemical reaction at work, something we've never observed before? Researchers are still investigating this mystery. And now, let's look at one more property of light: polarization. Polarization refers to the way light waves vibrate in a particular direction. When astronomers observe a comet through telescopes, they analyze not just how bright or colorful the light is, but also how that light is polarized. If we only looked at the light directly, we'd learn little more than brightness and color. But by adding polarization analysis, scientists gain a whole new layer of information. When sunlight bounces off the ice and dust grains on a comet, it slightly changes the orientation of the light waves. By carefully measuring those changes, astronomers can infer the texture and makeup of the particles covering its surface. For example, if the grains are fine and smooth, the polarization curve appears gentle. But if the grains are rough, porous, or irregular, the polarization signal looks very different. In this way, without ever touching the object itself, we can indirectly probe its composition and structure. Comet 67P showed a typical polarization curve, very similar to the comets we often see inside our solar system. In other words, nothing unusual. But the analysis of 3I Atlas told a very different story. Its dust grains appear to be smaller than those of normal comets, and the structure of the material seems to be extremely porous, filled with countless tiny voids. So while its outward appearance may look comet-like, the building blocks inside are not the same. In summary, from a distance, 3I Atlas may resemble Comet 67P, an icy body with a dusty tail. But deep within, it carries the fingerprints of another star system. Now, let's step into the realm of imagination. What if we could send a spacecraft, like Rosetta, to intercept 3I Atlas and explore it up close? What scenes might unfold before our eyes? From a distance, 3I Atlas might look like an irregular, lumpy block of ice, much like Comet 67P, scarred with cliffs and deep valleys. But as we draw nearer, the differences would become clear. Across its sunlit surface, columns of carbon dioxide gas would erupt like white plumes, mixed with reddish dust sparkling in the light. Over time, that reddish glow would shift to green, as if the comet were changing its breath. Through the spacecraft's cameras, we'd witness a stark alien landscape. Ice and dust interwoven, newly exposed surfaces gleaming in the sunlight, while jets of gas stretch outward, forming a long, luminous tail that reaches into the depths of space. In overall shape, it might still resemble Comet 67P, but its colors, its gases, and the very way it scatters light would all belong to a different world. Imagine the familiar landscape of 67P, but painted with the chemistry and colors of a star system far beyond our own. That is how we might picture the true face of 3I Atlas.